Okay, we're going to look at an exponential equation now, and let's just get started here. We got 3 to the x plus 1. I find it a bit easier to look at this as 3 to the 1 times 3 to the x. Well, that works. You write down the base, you could go x plus 1. But hey, there's so many times when factoring is an important thing to be able to do. And the way these types of questions work, you see 3 to the x is in both of these. So you can factor. It's a common factor. 3 to the x times 4 gives me this, 3 to the x times 4. 3 to the x times 3 gives me this, 3 to the x times 3 here. And so this is perfectly legitimate because I took out the common factor. But hey, 4 plus 3 is 7. So I divide both sides by 7. 63 divided by 7 is 9. And 9 is really 3 squared. Well, 3 to the x equals 3 squared. So x must equal 2. And that's it. Let's try this question. Well, it's a little bit different. 3 to the x to this scary looking negative 2 over 3. You add 12 to get started. You divide both sides by 3. And it's best to think of 4 as 2 squared. Powers of primes almost always is a good idea. Now, how do we get this x by itself? Well, the trick here is you write down, you look at this exponent, and you turn it upside down. Instead of negative 2 over 3, you raise both sides to the power of minus 3 over 2. You flip it, you invert it. Well, now when 2 cancels with 2, this equals 1. You get your answer, x. Now, 2 times minus 3 over 2, the 2's cancel. You get 2 to the minus 3, and that's your answer. And a lot of people go, oh, that's it, I got my answer. But you'd lose a mark because whenever there's a 2 there, if it's an even number, there's always 2 different answers, positive and negative 2 to the minus 3. So positive and negative, 1 over 8. That's 1 over 2 cubed, 1 over 8. There's your answer. That's it. That's how it works. I think, yeah, we'll leave it there and we'll do the trigonometry in a separate spot.